Hello, welcome to the demo presentation for Assignment 2, AWS Cloud Implementation of the Cloud Foundation course in Semester 1, 2025. My name is Pham Nghia, and today I am going to demo all the tasks that was given in Assignment 2. So first of all, we will start with Task A, which is to create a new VPC. So here, I'll go to the VPC tab. Once we reach the VPC dashboard, first we create a VPC. So in this task, we cannot use the VPC anymore, so we will use VPC only. So here, I will enter my SID and gives it a IPv4 CIDR, that's 16. That's it. Now I create a VPC. The next step in the assignment is to create one public subnet and one private subnet for each availability zone. So here, I press create subnet. Here I will choose the VPC that I just created. So we will have two availability zones which is the first one in US East 1A and the second one in US East 1B. Each of the availability zones will have one public subnet and one private subnet. So here I will name the first subnet public 1. It will be in US East 1A, and I will choose the subnet block of 10.0.1.0/24. So it fits the requirements that each subnet has a maximum of 251 IP addresses each. Next, we'll create a new subnet. This one will be private 1. Will still be in US East 1A, 2, and dash 24. Now we can add the public 2, which is in US East 1B. And using the next IP. And lastly, private 2. Once I've entered all the new subnets, press create subnet. So now we have 4 subnets, one public and one private for each of the availability zones. So now I will go to Internet Gateway and create a new Internet Gateway. I will call it my SID IGW for Internet Gateway. Here I will create it. Well, first, the next step for this is to attach it to the VPC that I just created. It's simple as that. Now that I've done with the Internet Gateway, we move to the route tables. Now we will create a route table. We'll call it public route table. This is important because this route table is used to associate with the public subnets. And later we will create a private route table for the private subnets. So the VPC is still this one. We create a route table. Now we will edit route for the public route table where we add route from anywhere to the Internet Gateway that we just created. Exactly. We save changes. That's that. Now, the last step is to create the route table for the private one. So private RTB. I will select a VPC, which is this one, create route table. Now, once that we have two route tables, now we can associate the subnet. For the public route table, let's associate the public 1 and public 2. And for the private route table, of course, we will associate them with the 8 with the private 1 and private 2. Well, that's the end of task A. I've successfully created a VPC that has two availability zones, which each has one public subnet and one private subnet. And I've ensured that the public and private subnets are associated with a route table that are relevantly configured. For task A, I use AWS Academy Module 5 Networking and Content Delivery. Also, a video by Rahul Wah, AWS How to Set Up VPC, Public-Private Subnet, EDC. Also, I use the Amazon documentation on Virtual Private Cloud. Now, once we're done with task A, which is to create the VPC, we can move on to the next task, which is to launch a static website with EC2. So first, go to the EC2 dashboard. And in here, the first thing we'll do is to create a security group. Here, we'll name it Web SG or Web Security Group. And this would be able to allow SSH and HTTP as per the assignments or the task B requirements. So here we'll choose the VPC that we created in task A. And to allow both SSH and HTTP, we'll create inbound rules for this security group. So first, we'll allow SSH, here, SSH, from anywhere to anywhere, or 000. And we will also do the same for HTTP, to 000, or anywhere IPv4. And we create the security group. Once that is done, we can now finally move to instance and launch a new EC2 instance, which I will call as 4.2.2.8.630, which is my RSID, /EC2. I will use the default Amazon Linux 2023 AMI, which is free tier eligible, and also the T2 micro instance type. For key pair, I will choose Valky, and this is the important part for network settings. Press edit. Now we will choose the VPC that we created in task A, and make sure that the subnet is from either public 1 or public 2. So it's public 1, so I'll keep it here. For auto-assign public IP here, we wouldn't want to enable it. Well, that's because in the task B requirements, it asks us to assign a permanent public IP address to the EC2 instance, which we will do in a later part. So now I will keep this disabled. And you remember the security group we just created. Now we will select the existing security group, which is Web Security Group. This we leave the same. Now we can launch the instance. Well, the instance has been successfully launched. So now what's next? Well, go to the instance. We need to create an elastic IP for it. Here, USE1, we allocate it. Now we will associate this elastic IP address to the instance that we just created. Now associated. Well, done. We finished the permanent public IP address for the EC2 instance. So now what? Well, we move back to instance. Well, this doesn't have any instance because you need to reload it. Here, showed up. Now we'll connect to this. Press connect. We'll wait a bit for the console to load up. So now, sudo su dash, we move into the root directory. Now we will install httpd by using yum install /y httpd. It'll take a little bit. All right, the installation is complete. Now we'll move to the directory of HTML, var www html. Once we're there, we use widget and go to the assignment 2. We will copy this address. We paste it in. This will allow the website to get the resources of the website, like the index, HTML index, the CSS, and the JavaScript. Now we will have to unzip it. Unzip static website .zip. Enter. Well, when that is done, we just have to use systemctl start httpd. When that is done, we can move back to the dashboard, copy this link, and paste it in. This is because this thing hasn't finished starting yet, so we will wait a bit. Go out. We press reload once. Well, you can see 2 pass checks and copy that IP address. And voila, we got the website running using EC2 instance of the cafe. Well, that's the end of task B. For task B, I use the AWS Academy Module 6 Compute. Also, a YouTube video by Viska Jha hosting a website on AWS EC2, Amazon Linux. Also, I use a website from the Medium hosting a static website on AWS using EC2, a step-by-step guide. Now that we have finished task B, we'll now move on to task C, which is to deploy the same website in task B, but now using S3. So now we will move to the S3 dashboard, S3, and we will create a bucket. We'll use general purpose bucket, and we'll name it mysid dash S3. For object ownership, I will use ACL enable. This will later allow the resources or the templates that we use to be publicly accessible. Right. And for this, block public access settings for this bucket, we turn this off so that the public can access the website. I will show you later on. Acknowledge this. Bucket versioning, disable, all right. And now we will create the bucket. Wow, it doesn't let the uppercase there. Now we use S3. That's great. Now that we have created a bucket, we press on the newly created bucket. So here, first we need to upload the files and the templates for the website. First, I'll add the files. We have it, study website. First, I add the index.html, then add the folder. CS folder, upload, yes. And here, study website, images folder. All right, now we upload them. It will take a while. All right, now that is done, then close it. Now we'll move on to properties. Scroll down to the bottom, and we move to study website hosting. In here, we have to enable it, and we choose host the study website. And for index document that I just added, I use index.html. Our document, we can forget about that. We save. Let me check one more. All right, we save changes. For this, in the permission, I've already turned off the block all public accesses and the object ownership in the access control list. So now I go to object, and this part is very important. So first, I will tell you about this. In index.html, this is the URL where you can enter the website. Let me show you first. You open this. This says access denied. So why is that? So in this part, in the bucket, in order to be able to access the website, you have to go to the bucket here. And for all of this, we need to make them public using ACL. By doing this, we allow people to be able to access our website. Setting public, close it. Now we come back, reload. Voila! Now we have successfully launched a website using S3. For Task C, I use AWS Academy Module 7 Storage, and a video by AWS Made Easy, how to host a study website on AWS S3. Host your study website on AWS S3 in 5 minutes. Now that we are done with Task C, we will continue on with Task D, which is to deploy a website in Task B, but using Elastic Beanstalk. So now we'll go to Elastic Beanstalk, find it, and create application. We'll use web server environment. The application name will be mysid -elb. Right. Will be a managed platform. We'll use PHP. Now, for this, we'll upload our code. We'll use local file, and for this, we will have to choose the zip file, the resources that we need to use, right? And single instance, free tier eligible. Oops, I forgot the version label. I'll call it version 1. That's neat. Press next. Now we'll use an existing service role. We'll use lab role, the key pair of Valkey, and the lab instance profile. Press next. This next step is to set up networking database and tags. So now we'll use the VPC. This. And we will choose US East 1A and US East 1B. Right? We will now move past this. We don't need this. For the traffic and scaling, we'll leave the container as default. And for the EC2 security group, we choose web security group. We'll leave this by default. That's good. We'll press next. For health reporting, we'll use basic. And we can turn off manage platform updates. Email notifications if you want the notifications for events in your environment. This we leave it. All right. Right. Press next. So now, for review, I figured all this. All right. Seems right. All right. Submit it. It will take a bit. Now the Elastic Beanstalk will launch the environment, which will take a bit of time. We'll wait for it. Well, the deployment has been successful. Now, we can enter through this. I have successfully launched a website using Elastic Beanstalk. For Task D, I also use the AWS Academy Module 5 Compute and learn it all, a YouTube channel by watching the video host a static website in 5 minutes for beginners, AWS Elastic Beanstalk. Now that we're done with Task D, static website with Elastic Beanstalk, we'll move on to autoscaling and load balancer of Task E. From this task, I have already done all the steps and finished making the website in Task B highly available by deploying the EC2 instance in the second availability zone using load balancer, auto-scaling group, and scaling policy. So now I will tell you all the steps that I took in order to do that. So here, go to instances. The first thing you want to do is to create a image for this. So you choose the instance that you create in Task B and press create image. Here you enter the image name, the image description, and then you press create image. So here in the AMI, you can see that I have created the image for this. So what's after that? So next you would go into the target group, which is this one, and you would press create a target group. Here you choose the instances option, name the target group. Well, for me it was my SID/TG, and leave this as HTTP. And then you choose your VPC, like this. Leave it as HTTP1 and press the health check. Yeah, so this is my target group. And then after creating the target group, you go to the load balancer. Here, you press create load balancer. Remember to choose the application load balancer. Here, I'll create it. And you name your load balancer. Use internet facing and IPv4. Here, for network mapping, you would have to choose your VPC that you created in task first. And then for ability zones, choose both of this and make sure that both of it is public. So public 1 for the first availability zone and public 2 for the second availability zone. And security group, choose web security group and leave the default. Now, for the target group that you just created, choose the target group you just created. For this, because it already belongs to another application load balancer, so I cannot choose it. But if you just newly created your application load balancer, you have to choose this. And for these, you just leave them. These are this default. Okay. Now that you have created your launch template, you have created the target group and the load balancer, time to create a launch template. So what is a launch template? So when you press create launch template, it will ask you for the name. You can name it and the template version 1, version 2. And I highly recommend pressing on this to provide guidance to help set up the template. So for this, you have to choose your image. So here, press my AMI and choose this image. And for instance, you should use T2 micro for the free to eligible. The key pair name should be Valky. The subnet, in this case, you don't have to pick. And most important that you choose a security group for this, which is web security group. And for this, you just don't have to do anything, and you can press create launch template. But since I already done it, I have it here. And for this action, we press on the create launch the launch template that you just created and create auto scaling group. Here, I will guide you through the steps. First, name your auto scaling group. For example, I'll name it something new. This, my SID. Oops. 6. And I'll name it ASG, now 2, maybe. And I'll press next. Here, you have to choose your VPC, and you have to choose the 2 private subnets. best effort, balance best effort. And you have to attach it to an existing load balancer, which will be the target group here that you created. No VPC lattice service. You should turn on elastic load balancing health check. Next. And the desired capacity, this varies, but I'll use 2. The minimum capacity is 1, and the maximum desired is 3. And we will have a target tracking scaling policy of target 60%. And instant warm-up is 300 seconds. Alright, just keep this as default. I would recommend clicking on Enable Group Metric Collections within CloudWatch. Here, this is add notifications, optional. That's next. And for this, you should add name, and for the instance, this will show up in the EC2 instance tab. I'll call it instance, sys or instance. And next. But there, you get the gist of it. That's how you do it. This is just the review of all the steps that you just did. So here I'll show you. It will take a while to launch this. So after that, you can go into the target group, click on it, and you will see the 2 instances are created. See, I named it instance. Now it's healthy. You can also go to the load balancer, and then click on the load balancer, click on the DNS name, paste it. Here, the website shows up. All right, and the last thing I want to show is that here in the instances, you can see the instance running. There's the instance and instance. Those are the instance that was created using the autoscaling group. Well then, I have finally done it. I have created the autoscaling group and load balancer for task E, enabling the task E website to be highly available. That's the end of task E. For task E, that's where I use the most references, like number 10, AWS Academy, Module 10, Autoscaling and Monitoring. A video by Rahul Wah, AWS Autoscaling Explained, Ultimate Tutorial Live Demo, Part 18 in YouTube. And also AWS Elastic Load Balancing and Amazon EC2 Autoscaling in the AWS documentation, and another AWS documentation in creating autoscaling groups using launch template.
Now that we're done with task E, autoscaling and load balancer, we'll move on to task F, which is to host a static website using EC2, but this time the website used to store data in the database server. Since I already done this task, I will be guiding you through all the steps necessary to be able to fulfill the requirements. So first, go to instance. So here you can launch a new instance. So in the requirements, it asks you to create a new EC2 instance named dynamic website. Here, write dynamic website in. Right? And also it asks to use Amazon Linux 2 AMI. Next, using T through micro instance type, the key pair of key. Edit this and choose your VPC. This should be enabled. All right. And make sure that the subnet has to be one of the 2 publics in the 1 or 2 availability zone. We select a existing security group. Just like usual, choose web security group. But for this task, go open advanced detail. For IAM instance profile, choose the lab instance profile as per the requirements. And lastly, for this, choose V1 and V2 token optional. And for user data, you can get it here. I already copied it here. So I will copy it and then paste it in. And then when everything's done, you can press launch instance. I already have it, so I'll cancel it. So as you can see, the website here is running. That's right, okay. We'll now move to the security group. This is important. We will have to create an RDS security group. Now press security group, call it RDS underscore security group. This will allow not SSH. This will allow Aurora and SQL. All right. Then choose the VPC. For this inbound rule, you should choose SQL, Aurora, and then go to here and look for the security group, the web security group. All right. When that's done, press create security group. So I already have that, as you can see here. Security group name, RDS security group. Let you see. Here, allow Aurora SQL, right, to the security group. Here, to this one. All right. So what's after that? Then we go to the RDS. I already have a tab open here. Then create a subnet group. So this subnet group is simple. I would call it the private subnet group or private subnet group SNG. And you can write the description private. Why do they call it private? Well, here I will explain it right now. For ability zone, you choose USDs 1A and USDs 1B. And for these subnets, you should choose the private one and private two, because this is a database, so you don't want to assign a public subnet to it. So private one, private two, here are the two. Now create, but I already created it, so I cancel it. Then you can move on to the part where you create the database. So first you create the database, standard create, that's right. Now go with MySQL, scroll down, all right. I'll use the free tier, single lazy DB instance deployment. I just named it database. So here it's database 2. And you need this. You need to name, just leave it as admin. And password, you can write whatever password you want. Just confirm the password. This will be important, so you have to remember the password and the username. For the instance configuration, I use db-t3 micro, and this I leave the same. I also press connect EC2 complete resource to the dynamic website. All right, and then you choose an existing DB subnet group, which is the private subnet group that we just created. Public access, of course, is no, because this is private. And for the VPT security group, we created a RDS security group just now. I'll click it. All right. So what more? This is good. Password authentication, that's correct. Sudo configuration, this is important. Open additional configuration, name your database. I named it with my SID. So after you created this, all of this is done. All right. You press create database. And because I already done that, I will click cancel out. But it would take about 3 to 4 minutes to create this database. And when it's backtracking, you can go into the database here. You were able to see the endpoint and the port. And also, you will be able to see that this EC2 instance has been connected to this database. So we can click on it, which will open this one, but now I open a new one. All right, like this is the state. You see here the dynamic website. I will open it. Well, at first, this wouldn't appear because you have to go to the settings. It will ask you for the endpoint, which is this. You can see the endpoint here. You copy it and you paste it in here. The database name, which I just said that I use my SID for it, and the username and the password that I asked you to remember. And when you press save, you will load this. So now it's fully functional. You can add something. For example, store, say Hanoi. The item is roasted chicken or something. And for quantity is 5. I can submit it. And it's here. Now I can also delete it. Well, with those steps, I have been able to deploy a dynamic website and has that website being in a database to store data. And that is the end of task F.
For task F, I use AWS Academy Module 6 Compute, and also I rewatched a video by Vikas Jha hosting a website on AWS EC2 Amazon Linux YouTube. And I also used AWS Academy Module 8 Databases and Code Cloud, a video called AWS RDS Tutorial, setting up a database in Amazon RDS. Of course, this wouldn't be possible if I hadn't attended all the tutorial and lecture class. Now we'll move on to task G, which is the AWS architecture diagram for this assignment. The architecture you see right now shows the complete cloud environment built for task A to task F inside a custom PVC, spanning 2 availability zones. Each availability zones contain one public and one private subnet, and the public subnets route internet-bound traffic through an internet gateway using the public RTB route table, while the private subnets are isolated using the private RTB or private route table. For task B, a study website is hosted on an EC2 instance in a public subnet with an elastic IP. The same site is also deployed in task C, but this time using Amazon S3, and in task D using Elastic Beanstalk, each offering a different approach to hosting a website. And for task E, it introduces an auto-scaling group that deploys EC2 instances across both public subnets. These instances are managed by an application load balancer that distribute incoming traffic and improve fault tolerance. All web-facing instances are protected by WebSG, or Web Security Group that was created in Task A, which allows only HTTP and SSH access. And finally, Task F adds a dynamic website hosted on a public EC2 instance, which uses the lab instance profile IAM role and connects securely to an Amazon RDS MySQL database. The database is protected by the RDS SG or the RDS security group and only accepts connection from EC2 instance in the same VPC, ensuring secure communication for the database. And that's the end of Task G. For Task G, I had to revise the modules in the AWS Academy from Module 5, 6, 7, 8, and 10. I also used the website Medium from Basics of AWS Cloud Architecture written by Safi. And with that, we conclude this video presentation. And for the next slide, you will see the YouTube video link that I will be adding after the YouTube upload. With that said, this is the end of the presentation. Thank you for watching.